So I thought I'd show you how to use a TI calculator to do this derivative work. In case maybe you already know, but I suspect you don't, unless you've been shown before. So go look at my handwritten work that I did to get the setup. But here's the difference in my x's. Here's the differences in the y's. Now remember, what I'm trying to do is minimize the distance. So I need to get the distance formula here in my calculator. So as I said on the paper, trying to do this derivative is a royal pain. So the theory works pretty well. So what I got to do is, remember, I got to do x sub 2 minus x sub 1 squared. Well, that's in my y1 function. So down here in y3, I did the square root. As here, let me clear this, clear that. So what I did is later, let me even clear what I've got there. Now we can clear my history. Come on, clear. There we go. So let me clear my key press history for you. You see, nice thing about this application, it shows what I'm pressing. So I'm gonna do second square root. Now here comes the part that you probably don't know how to do. So I want to take the stuff in y1 and square it. So all you got to do is do vars, press vars, come over to y bars, type a 1 because that's where the functions are, and then I want y1, and then want to square it. Why did I do y0? Did I type the wrong thing? No, just a minute here. Let me redo it. A second. Let's see. I'm busy gabbing. I don't know what I'm doing here. Function 1, yeah, y1. Okay, yeah, that's better. I don't know what happened. And then I'm going to square it, and it does order of operations, so I don't have to worry about parentheses because it's taking whatever's in y1 and plugging in a value and squaring it. Okay, then so now it's just the Pythagorean theorem, right? The distance formula. So x sub 1 minus x sub 2 minus x sub 1 squared plus y sub 1 minus y sub 2 minus y sub 1. So that's just that y2 function. So again, we're going to do vars y bar, arrow over to y bars, do a 1, and then 2, and we're going to square that baby. Now we don't even want that graph because that's just the distance formula. I want to find the derivative of that distance formula. So down in y4, what we're going to do is we're going to do math. Now let me clear out this key press for you. We're going to do math, and then 8. Math 8 is n deriv. And we want to find the derivative with respect to x of the function in y3. So I'm just going to do vars, y bars, function 3. And then I want to find over all x. I don't want a single answer. I want to graph the derivative. So I'm going to type in x there. And then I'm going to go up, and the only thing I'm really interested in that derivative graph. So I'm going to turn off all these other 3 functions. It doesn't stop the calculation. We just don't have to see them. So the way you do that is you put your cursor right on the equal sign and press enter, and it'll turn it off. Then down arrow. We're gonna enter to turn it off. I'm gonna come down to y3, enter, and that turns it off. Now the only thing that's going to be graphing is the derivative. Now the bad thing about the calculator is if the derivative is undefined at a value, it'll kick up an error. So you're going to know what your domain is. And we know the domain is from -4 to +4, right? So I'm going to go, but at -4, the domain doesn't exist. So the derivative doesn't exist. So I don't want to include -4. So what I'm going to do is I'm just going to go window, and I'm going to change my x min to -3.9. Then we're okay in that distance. And then positive in that range, positive 3.9. And then it doesn't, I guess it really doesn't matter what y is. We'll leave it at -4 and -1. Or you can just type in -4 and +4. Now I'm going to hit graph, and I'm hoping what we see is, now this graph's very fast because it's using the computer processor, but you see that critical value. Remember, this is the derivative I'm looking at, and when the derivative is equal to 0 or undefined, but there's no undefined places that's other than the endpoints. So we're looking for that value. The other thing I want you to look at is, I'm going to show you how to do this analytically too, but if you look at the graph, you see how all the y values are negative? So that means the function, the distance function is decreasing. There's a critical value at 0 there, and then it's positive. So if you think about that first derivative test, the derivative is going from a negative value to a positive value. So that tells me it's going to be a minimum. We could also even graph the second derivative or have it calculate the second derivative. Maybe I will with a calculator and let us do that. But I want to find that x value. So the way we do this is do second calc, and we were looking for a 0. So 2. And see, it's nice. It already says it wants you. What's my left bound? What's my right bound? I'll make a guess. Well, we're going to look at something after class, after the exam, called Newton's Rhapsody, Newton's method. And it's just, this is what the calculator does. So my left bound, I'm going to press enter. And then I know that 0 is before 2. So I'm just going to type in a 2 and see how it clicks off the other end. And then you can either make a guess or just hit enter again. Okay. And there's the 0. So that's where there's a minimum value happening. So when x equals 1.632-ish or 33-ish, that's where the minimum distance happens. Now they aren't. I don't think they're asking us for the minimum distance. I mean, we could if they were looking for the minimum distance. Now let me come back to y equals. The distance formula is in y3. So don't remember how I got that last calculated answer is in x. See, if I type the number x, the variable x with a calculator, see, it does that last calculated answers there. So what I'm going to do is use it to find the actual distance. So I'm going to go functions, and that function is in 3. The distance formula is in 3. And then you just do it just like I mean, you could type in the number, but since x has got the number, so that's the actual distance. If we were to do here, let's show you this. If I were to do negative 1.5, not if I were to do 1. Whoops, what did I just do? Bars, y bars, let's see, y bars, function 3. Let's just do this for 1.5. It should be bigger. No, let's not do 1.5. That's too close to 1.55. Let's go to 1.4. That number should be bigger than the 1.55, right? Because the function's decreasing until that critical value. And sure enough, it is. And how about so it's decreasing until the 1.635. I guess I could have gone 1.5, and that would have been okay because that was less than that. And then it should be decreased. If I pick a number like 1.7, it should be bigger than 1.55 because remember that's the minimum distance. So just a minute here. So it does ask us how close, so it wants the distance. So we need to look at here. Let me quit the screen. We are looking for the 1.55 number. Okay. So here, let me get a pointer going. Maybe that'll show up better. So that is the actual answer. But to get there, we've got to show some calculus. Okay. And as you've seen, sometimes the algebra behind it's crazy, impossible. And why do it? You know, we're showing where we understand it by showing, hey, I'm seeing what the derivative is going from a negative to a positive. That's the maximum. And I found the 0, found the critical value. Okay, what other thing was I going to show you? Oh, how could I could use the second derivative test with this. And the way you do that, actually, I haven't tried it, so let's see if it happens. If it's a minimum, the original function should be, the distance formula function should be concave up at that 1.6 number, right? So what we're going to do is we're going to do math, and I don't have to calculate the derivative. I'm not going to do it by hand. What I am going to do is I'm going to do this though. Math 8. I want the derivative of the first derivative at x, and then do vars y bars function. Let's see, what was it? Derivative was in 4. So I'm going to type a 4, I hope. Yeah, and then it'll take the derivative, hopefully at 4, and then I'm going to be really lazy and just press that up arrow to get that old 0 and enter. And let's see if, now this should be a positive number if it works. And it is. So you see how that's a positive number? So that tells me that the distance function is concave up at that point. So yes, that's the minimum. So that's the second derivative test. Okay, I hope it's a lot of tech here. I hope it didn't overwhelm you, especially going into an exam. But you know, keep it in mind. The questions I asked you in the exam are not like this. You know, not quite so nasty. I'll ask you the math, and I'm not going to ask the algebra of it yet. Okay, so hopefully this helps.